Yeah.
All right. Okay, I think. Oh, like a little hot. How's that? Is that still working? Cool. All right. I think we're going to get started. I think we're already live streaming to Facebook. Is that right? Cool. So hello, people on the internet. But yeah, so we're going to get started up here. We're going to share some updates on what we've been up to and then introduce our speaker for tonight. So hopefully y'all got your newsletter back in July. You've had some time to peruse that. If you have any things you'd like to see in the newsletter in terms of articles or yeah, anything, recipes, you can submit that to Cecily Franklin. She's the editor of our newsletter. We've had several walks since our last meeting. Oh, this keeps sliding. There we go. Yeah, so I got some photos here from Crooked Creek. That was back at the end of July, right around when we started to get some rain. So that was, we found some stuff there. Did anyone make it out to that walk? Yay! Why this one's on the fritz? Anyway, Sycamore Island on the 30th, a week later, found some incredible things there. And that was with Allegheny Land Trust. They took a boat out to the island in the middle of the Allegheny River. This is the tree Volvariella bombacina, not often seen. And then this is Wilson slime mold that has never been reported in Pennsylvania before, at least on naturals. This Lycogata conicum, really cool find. I would have lost my mind if I saw it. How bright those colors are. August 12th, we were at Bethel Green. Again, some cool slime molds. That's the Carnival Candy slime mold there on the right. Arceria, is that denudata? I forget which, yeah. And then on the left, that's Pisolethus. Yeah. Die Maker's puffball. Okay, cool. Nice. And then the next day at Voice Mayview, Julie led 2 walks in a row. Can you believe it? So we got some nice Resupinatus there, some smoked oysterlings, and a nice table full of mushrooms from Voice Mayview Park. So if you were able to make it out to one of those walks, yeah. Cool. We'll just turn this off. I don't know why this one is being so weird. Y'all hear me still? Cool. All right. In terms of upcoming walks, we don't have any on the books the rest of this month that I'm aware of. So if you are a club identifier or mycologist and you're feeling inspired to put a walk together, we have the ability to announce pop-up walks and post them to our Facebook group. So get in touch with Cara if you want to do a walk any of the weekends coming up. Otherwise, our next walks are going to be in September. So September 16th at Audubon Greenway, that's with Allegheny Land Trust. Another walk with them, October 28th at Dead Man's Hollow. Those are always led by Julie. They cost $5, and registration is limited to who signs up in advance online. Anything else you want to share about those, Julie? Cool. In terms of our monthly meetings, we've got 3 left this year. So next month, we're bringing Dr. Sarah Meese from California University of Pennsylvania. Now it's like West Penn, California. She's going to talk about the benefits of fungi in wetlands. In October, we'll have our photo contest. And then in November, my brother, Chef Sam from Round Corner Cantina, is going to come do a cooking demo. Yeah, so that'll be fun. If you didn't know, you can print your own field data slips now. You can get on fundus.org and print them out yourself. They've got this template on there. And we're working on creating some custom ones for the link-off foray coming up. So I'm excited to see what those look like. Yeah. If you haven't checked out our Spreadshirt yet, there's a lot of cool stuff on there. I have been meaning to buy something from this. Every time I give this presentation, I'm like, oh yeah, I should buy one of those t-shirts. They look pretty nice. But yeah, you can customize it. So there's a lot of options in terms of color, which pattern. And I mean, you could get a nice little chef's apron with the Western Pennsylvania Mushroom Club logo on it. That's so fun. All right, I've been plugging this the past couple meetings. If you don't know, if you don't have this on your phone yet, download it. It's amazing. It works so much better than the website version. But yeah, you can just go through the menu and select what features you're observing about a bolete, and it'll give you the top suggestions, tell you whether it's edible or not. There's a lot of different species of boletes that you can be finding in our area right now, and this tool is really helpful at figuring out at least what group of species the bolete you're looking at might be in. Can help rule out some of the toxic ones, the ones you want to avoid. So check out that app. Really can't recommend it enough. All right, so I mentioned earlier we have the link-off foray coming up at the end of September. So I'm going to share some more details on that. This isn't an official part of the foray, but on Thursday night in Cook Forest, we're going to be hosting another fluorescent foray walk. So we tried this out last year, and it was a blast. We had only about 10 or 15 people show up, I think, because we announced it the day before. And that was intentional. I was like, I'm leading a group of people out into the woods to look for mushrooms at night. Like, that's dangerous. I don't want a lot of people there. So I'm hoping, we don't have like 100 people show up. Hopefully it's more like a small group, like 25 or so. But we'll mostly just be hanging out. There's a flat trail there. I don't know if anyone's ever walked the old logging road at Cook Forest, but it's a trail that borders the old growth forest on one side and a pine plantation on the other side. It's a really nice flat trail. So it's pretty easy to just walk that in the dark, not get lost. So we'll be meeting in the parking lot there at 7:30, and I'll be leading that walk. And if you have a UV flashlight, bring it. I'll bring an extra one. I'll bring some extra protective eyewear for folks. And we'll post something on the Facebook group about what flashlights are good and which ones, oh, did we lose a battery? Yeah. Yeah. So there's a lot of cheap UV flashlights out there that don't work as well. They make everything look kind of purple. So you want to make sure you're getting one that has a special glass filter on the end of it that blocks all the visible spectrum light and just lets the ultraviolet spectrum light through. So it shouldn't make everything purple. It should just be kind of a faint bluish purple light and things either reacting strongly or not to the presence of that. So it's pretty fun if you've never tried this. Just shining lights around the forest, and then all of a sudden there'll be glowing stuff over in the distance, and you check it out. So it'll be a pretty casual walk on Thursday night. And that's where we're going to be meeting, where the little blue star is there. So if you're familiar with Cook Forest and the Forest Cathedral area, it's up on the back end of the Forest Cathedral. And we'll probably do some sort of a loop just like down the old log road. Last year we made it down here somewhere, checked out a spring, and walked back.
Sure, Stephen's gonna make sure he has his phone.
Yeah. May or may not have almost lost my phone last year. That was fun. So Friday, the main event in Cook Forest is on Friday, and that'll be at 10 o'clock. We'll meet at Picnic Shelter 2. So if you're not familiar, it's this one down here off of the main road there, Comstrunk Road. And yeah, there's plenty of parking there. We'll get started around 10 o'clock. And last year, a lot of folks walked like right in that area. And some folks drove up to some different parts of the park. So depending on who's leading walks there, we might spread out and hit some different parts of the park. Then we come back together at the shelter and do the whole like identifying all the mushrooms and sharing out stuff, just like we do at the end of every walk. But since there's so many people and so many mushrooms, we're usually there until the afternoon, way into the afternoon, even though we start at 10. But that's an incredible walk, highly recommended, and that is free. So all of these events so far are free, but the main foray happening on Saturday has a registration fee associated with it. I believe it's 70 for non-members and 50 for members. Is that right? And 30 for students. Nice. So this is our schedule for the day. As you can see, it's a full day of mushroom-related festivities. Right, there's food, there's music, there's games, there's going to be vendors this year. So what did I want to say? Missy May Tutus, Wobble Mud Studios, PA Mushroom Company, and Cedar Bridge Botanicals will all be there vending stuff. So bring, yeah, come on, show it off.
So I was shocked. It's like all of these vendors, right? So I brought some things. You like it, perfect talk. So I brought some things you can expect from the vendors. So Expo, you'll be there selling throwbacks of wine and what else? Some fresh mushrooms. So, this is a tutu, so not a tutu, but look at this lovely mushroom bag. These doors. To the vendor. And I also brought Wobble Mud Studios. Art teacher, that's from Hammock. And please bring some cash because those that make prefer cash. And the Cedar Bridge Botanicals is like a friend of the sister who grows exotic house plants. So she'll be there with probably probably plant traps and like cool house plants. And also Wild Ones of Western PA will be there. They're going to
Nice.
coming up.
Yeah. In terms of the band, we're bringing in the New Age Adinas. Is that how you say it? From Wheeling, West Virginia. So I don't know. We'll see what that's all about. Yeah, we'll have some yard games. Come hang out, have fun. Yeah, guided walks in the morning, speakers in the afternoon. There's an auction. There's a cooking demo, right? Anything mushroom that you can think of, we're trying to include it. Oh.
Volunteers to help us. If you like to put something, you can all here. I'm trying to come together. I'm teaching you, taking care of you. About 20 people. Food for everyone for lunch. Thank you. I'm Mike Hendrick, by the way.
Yeah. So just to reiterate, the lunch and the dinner is potluck. So if you like to cook, or if you even just have the capacity to go to the store and get some things to throw together, a salad or like some chips and dip, you can save your receipts, send them to us. We'll reimburse you for the cost of the groceries. We just need folks to volunteer to bring some food for lunch and for dinner. And get in touch with Mike Henry if you're interested in helping out with that. And then did you have something to add, Jared? All right. A couple more details about the link off foray. So our speakers this year, we're bringing in Alan and Arlene Bassett They're world-renowned mycologists that have written dozens of mushroom field guides, particularly pertaining to the species found in Eastern North America. Arlene's most recent book is all about polypores, and that's what she's going to be presenting on, how to identify polypores. Yeah, they'll both be available for signing, and we'll have a meet and greet in the afternoon. So if you have a field guide by then, you want to get autographed, bring it. They always love signing stuff. And we'll also have Stephen Russell presenting. He's the founder of the Hoosier Mushroom Society, and he'll be presenting on his DNA research. He's really one of the cutting edge folks in terms of amateur mycologists, right? People who aren't necessarily professionally trained in this to go out and do DNA sequencing work. And his project has been getting to know all of the mushrooms that grow in Indiana. So he's been going out, collecting specimens, doing the DNA sequencing work, and he's been working with some of the folks in our club, like John and Garrett. Some other folks have gone out to the Indiana forays and helped out there. So we're really excited to be bringing Stephen here this summer to sequence all the mushrooms that we're going to be finding in Pennsylvania.
That's another area where we're going to need volunteers. If somebody wants to volunteer to help, go through the process of doing DNA, we're going to be doing great activity today. Taking photos, putting in the centrifuge, PCR, all that stuff is going to be done there. So, if you want to see it, you want to have fun. And also, if you come to the rain, you find a mushroom, look at the sequences. So you might find a new species. But we need volunteers, so it's going to help.
Sarah, you want to say, speaking of volunteers, do you want to address the benefits of volunteering?
Sure. So one of the other things is, if you volunteer, we have a reimbursement system here. So if you want to come set up on Friday and help me out, move some tables and chairs into 2 hours to get a free t-shirt. If you want to do something all day, you'll be reimbursed with a full cost of the free t-shirt or something in between. Something. So we're trying to, for the point your time in, then you get something back this year. So again, welcome to come here, they can come speak to me afterwards.
Yeah. Does anyone have, is that the foray t-shirt from last year, Mike? Can you show that off? So last year was the first time we got a special t-shirt made for the foray. Yeah, so this year we'll have another special edition t-shirt. I think it's going to have a Xylaria on it. Yeah, so another drawing that Cara did. So that'll be fun. All right, here's a little update on our membership numbers. As of a couple days ago, we were up to 876 members from 484 households. Woo! Yeah, so thanks so much to all of you, whether you're a member or not, just for being here. But huge thank you to those who support the club financially through membership. That's how we are able to do things like our DNA sequencing project and all the other cool things that we do. All right, so our photo contest is coming up. The end of September is the deadline to submit. So if you're a member, you can submit up to 5 photos to our contest. There's no file size limit this year. In the past, they had to be kind of smaller files, so no size limit. Just send those to pamushroomclubphotos@gmail.com. Make sure you follow the instructions here. All the instructions to participate are on our website as well, under the photo contest. So yeah, that's really fun. I'm really excited to see all the submissions we get. And there are usually prizes for the winners. So you could win something pretty cool. I know you all are out there taking pictures of mushrooms, so send them in. We've got a couple new categories this year. Well, I guess one new category, mushrooms in art. So if you are more of a painter or sculptor, or you do some other kind of visual arts, you can submit a photo or some sort of representation of your work, and it'll be judged accordingly against similar things. Also, just a reminder that lichens are fungi, and so you can submit photos of lichens in our competition as well. Apparently that wasn't clear in the past. All right, so these are some things about membership. If you aren't a member and you're interested in joining, that's how much it costs and some of the benefits. Oh, and we have a Mushroom ID award to announce tonight. So if you didn't know, we have this cool little thing we do where you can send us a list of the mushrooms you feel like you're confidently able to identify. And Julie will go through your list and see if it seems right, seems accurate. And then if it does, you'll be awarded a button to acknowledge your skills as a mushroom identifier. And so we award buttons at all different sorts of levels. And once you get up to 150 species, you can submit a list to become an official club identifier. And we're really excited to announce that Josh Maurus has submitted his 150 list and it was approved unanimously by the board. So he's now an official identifier.
I have another button to give out. This was a surprise for Steven. So Steven submitted for his 300 button, but we don't have any 300. So I made him a custom 200 and 100 button until I could make an official 300 button for you, because it goes right from like 250 to 500. So this is your custom 300 button until we get an official one. Right? So isn't it?
Julie. I'll wear it with pride.
Don't get it wet. Don't jostle it around. Don't do anything.
Don't worry, I won't do anything too risky. All right, so we're almost done here. Next month, we're bringing in Dr. Sarah Meese. Sorry if I pronounced that wrong. Yeah, so she'll be talking about the benefits of fungi in wetlands, a little bit about her. She grew up in Harrisburg, PA, went to college at Bloomsburg University, then earned her PhD in Athens, Ohio in plant microbe interactions. Yeah, so she really studies the interactions between plants and microbes. Is really interested in wetland ecosystems, and is going to be talking about the fungi that live in those habitats. Any other questions or announcements before I turn things over to Cara for tonight's presentation? All right, well, Cara, I mean, I don't think Cara needs much of an introduction. She's the current vice president of our club. She's our most recent club mycologist, and she's really into macro photography and studying all the tiny things that we find here in Western Pennsylvania, which happens to include a lot of these entomopathogenic fungi. So Cara, come on up here.
Just need a short break while we set up some things.
We found it. Wait, did you get the right one? Oh yeah, that's the right one. Good.
Okay. I just got to share screen.
That's what I was waiting for.
Yeah, so the buttons are working.
All right, cool. All right, this is a new one for me. So I'm not just here to talk about just insect related into the past. Well, we're not. So we're talking about the entomopathic fungi, entomopathogenic fungi, forgive me, and other like fungi that kill things, and the different things that fungi can do to behavior to you know, that's interesting. Okay, sorry. So, wait. Do it. Not doing it.
It's right.
It's okay. How do I get it to do the thing? Oh, there, see? It's a one click though. Button.
Should be left. So that's forward, and then that's the laser pointer.
Right, but I mean, like, because if I have to, I can put it in this. Like, there, see? I did all these animations. I was like, one of them work, right? All right, so what you usually think about when you think of entomopathogenic fungi is the ones that, you know, the little thing comes out with the ball on top. There's two different here that you can find different insect destroying fungi. And we've got this one who Zygomacotta, which has a lot of the different, has some of the crazier ones, like the Massospora and you know, the fly death, and a bunch of other interesting ones over here. And then we also have the ones that are actually in the Ascomycota group, which is like when you think of, like, look, Pizizas are actually in the same subphylum as these guys, which I thought was kind of interesting. Whereas the other class we have is like its own little world over here. So in here, this is where you get the traditional Cordyceptaceae, like where you're thinking of the caterpillar death ones, and the fun little balls on top. That's usually in the Ascomycota group and the Cordyceptaceae group. But you get the Anchithomyces. Forgive me, my Latin is awful, so I'm just gonna like wing it. So you're just gonna be like, "Oh, is that how it's said?" And you're like, "Yeah, sure." So and they're very host specific. The different types of pathogens. We'll get into that later though. I'm so proud. The little things. All right, so there's different ways that they can be spread. And in some situations, like for Massospora cicadina, they are actually, like, that's where you have the cicadas that get infected with the fungi. And where it starts initially is when they're actually crawling up out of the ground, and they actually get infected through the roots of the trees that they're under. Not all of them get it. So whenever they're coming up, you know, they're infected, and we'll get into that later too. But you get the air, that's when the spores disperse through the air, obviously. Mating, that's another method that different insects can be pathogen or can get infected. Food, sometimes just eating something that has it in it can cause it to become infected. And environmental factors like if they commonly go through a different path or something, you'll find like maybe they'll rub against a certain plant and it will get stuck on their body, and then from there they can get infected. So we'll start off with the really fun one here. Massospora. There's actually a couple different species. That's why I didn't want to just put cicadina. They're finding there's actually multiple species. There's actually one in Africa. And what's interesting about the one in Africa is that it has a chemical that causes behavioral changes in it, and so does this. And they're both the one in Africa, I believe it's a sort of like amphetamine that's inside of it. And here it's psilocybin, or psilocybin, which is a hallucinogenic. So, and what also is interesting is it's convergent evolution. So it's not even like related. They just so happen to have formed it separately on their own, which is really fascinating. There's different groups, but it starts, like I said, whenever they climb up out of the ground, and they then go cling on to the tree, but it takes like 7 to 10 days for them to mature in their little crazy form. And as it takes that long for it to morph into an adult. And whenever the male cicada is infected with it, they once they're finally an adult and they're flapping around, they try to act like a female, so that the males will come and then they'll get infected. But what's crazy, if you look here, you see how that part of this thing is off. It's actually still alive, even though part of its abdomen is off. And that's actually the fungi right in there. And these guys, they fly around, and they're like flying salt shakers of death. And they just other ones are flying around, and they just spread the love. Also, whenever they try to mate, so the males will try to mate with these other males that are infected, and then they get pathogenized, and it's just a whole circle. So that whenever they finally go and die, they're living in these trees, and they die and they fall to the ground, and then there it is, the pathogens in the root system again, and the whole cycle begins. But they can actually, the females can also get infected. Obviously, it's mostly the males that kind of pass it along, but the females can also get infected, and similar things happen with the abdomen falling off, but it's less likely to fall off on the females. But yeah, it's crazy when you actually see this and they're flying around without butts. It's like, what? So this is in that same group as the Zygomicata. So these are the Entomopathogenic. All right, those ones. So it's in this phylum. I'll go through these ones first. So So is the fly death one here that we got. There's actually a couple, again, these are very host specific. Even with flies, sometimes they will only target a specific species of fly. For example, you have another one that infects snipe flies in particular, and it's the Furia ithacensis, which is this guy here. So that's a snipe fly. Whereas we have here just like your typical muscid fly. And it's interesting because it happens similar ways. With this guy, you can see how much more fuzzy it is. So it gets with this one, it gets a little bit more stuck to it, but it does cause behavioral changes. Once it's infected, it, targets the brain to cause it to want to go to higher surfaces. So I'm sure you've heard of cases with the things in Cordyceps that also have similar behavior, which is so fascinating that even though these are in different phylum, completely different phylum, we still have some similar behaviors in how they actually spread the love here. So with this one in particular, though, these guys, they crawl up to something high, like edge of a leaf, top of a tree, whatever they can, so they can spread as much. And then they get on there, they go spread out as much as they can, and then the hyphae actually kind of glue it to the leaf or tree or whatever that you find them on, and it comes out of their mouth. You can see it actually comes out of their proboscis. My husband didn't believe me on this. I was like, no, man, it comes out of the proboscis. The hyphal structures glue it right there. So yeah, so they help to glue it to it, and Yeah, it,
Underside of the leaf on both of these. Do you think that's right?
this one wasn't. This was on top of it. That one was actually, you're right. This one was underneath it, which makes sense because if it's underneath, it can spread it out more. But this one was actually on grass. Yeah, it was in Presque Isle. But yeah, so that's how they maximize the dispersal of the spores is by doing that. And like I said, very host specific. So here we have the mighty tardigrade, okay? Like I said, it can survive extreme heat, vacuum of space, years without water, extreme pressure in the deep sea, and high levels of radiation. But fungi can kill it. How I found this one out was I was having fun with my new scope and we were trying to scope some tardigrades. And I was like, what is this? I'm like, that is a tardigrade. But what is this? This is a, and I looked and, it was a fungi and I checked it out. Now I wouldn't say it's this particular one. It's almost impossible for me with my current homemade lab to be able to speciate with something that's microscopic right now. I'm just not that good. But it probably is in Balacephala. But but like the one that's known as Balacephala sphaerophora, and what it'll happen, these guys will get like little balls on it, but this spreads in a really cool way. So these guys, they actually will stick to they will stick to the cuticle of these guys, and they'll like the spores will work their way in through they have like, I don't know if you've seen tardigrades, but they have like this little tube right here. So these little guys will actually work their way in through here. And they'll just it'll keep growing and growing and growing. And this guy will keep checking it along until it actually like squishes its organs so much that it dies. Oop, wrong way. So, yeah. But then like once it's, wrong way. Once it's, these little tendrils will come out and then the little conidia will form, which is like little like thingies, little, I don't know, spore holder thing. So these spores will come off and then, they kind of hang out in the same area. So this is a pretty good example of environmental infection where, they're just hanging out in moss because they're moss bears and they, infect each other. Now, weaponized fungi. Now this is cool. So we can actually use fungi in some situations to kill exotic invasive species. For example, the spotted lanternfly. They're finding that there are some pathogens that some have been here since like they say the 50s, but they're finding Bavaria bassiana and the Batcoa major can pathologize the spotted lanternfly and actually kill it. Again, working with any kind of fungi or biological solution to destroy an entire species, you got to watch out and make sure it is very host specific. Then we have the spongy moth, formerly known as the gypsy moth. So just so you know which one it is. There's actually a fungi that will destroy them as well. And actually, I was wrong. I think that this is the one that was here since the 50s, and it's from Japan, I believe. And it actually will cause these guys to they'll climb up the tree, but they'll only climb up and then they get infected and they get these fun little things on them and spread the love again to other things that are climbing up, and they kill them before they can even become adults, which was really fascinating because whenever I was in the Penn State area, I noticed hundreds of dead spongy moths all over the place with this fungus on it, which I thought was so cool. And I tried to bring it home and take a sample of it, but it was day one on my vacation and I didn't have a dehydrator. So it kind of didn't last. We'll just say that. All right, now this one's a little, I know that this is kind of off of the, I just wanted to add this for fun. Let's just put it this way. So just deal with it. So the killer oyster. So this is a fungi that can kill and it kills insects. So I think it counts. So Pleurotus species, oyster mushrooms, they actually have, they can actually kill nematodes. They specialize in killing nematodes for extra nutrition because, let's admit, you're sitting on a log all day. Logs aren't the most nutritious things in the world. So it'd be great if you could get a little bit of, extra vitamins. So they, have evolved a way to actually kill these bad boys so that they can, as a nice feature to help them survive. Now what they do is they lure in the nematodes and the chemical, it actually smells like food to the nematodes, specific nematodes, because there's actually, different species of nematodes, but they actually kind of zero in on a specific kind of nematode. And so these nematodes, they come in and they're like, oh, it smells great. I'm going to eat this thing. And then once they get in there, the hyphae, which is like the fungal structures of the Pleurotus, actually will emit a toxin to the nematodes that induces paralysis and of the sensory neurons. Okay, so then, as you can see here, like the mycelium will wrap around it, and while it's paralyzed like this, and enter it through its mouth, kind of like the tardigrade, how it entered through its like little tube thing. Well, this also will enter through its mouth to get the nutrients from it, and it devours them from the inside out. Now, there are some nematodes that are resistant to this toxin, and they found that those ones lack a cilia-dependent predatory mechanism. So what's interesting is these nematodes actually have evolved a feature to help them live that actually also kills them. So, but these ones, the ones that are resistant to Pleurotus, or just don't even bother with it or get hurt by it if they do, they lack this cilia-dependent predatory mechanism, which I thought was really fascinating and interesting to ask. All right, so can fungi harm mammal or have mammals? I should have put an S there. How great I am at editing. Or have an influence on mammalian behavior? Yes, but not like you would think. Okay, so one in particular, there's a couple different things, but it's very gentle. Like it's not like what you would think. But one of the big ones that I found is Alzheimer's disease. They're finding that it's not how it. So they're finding that. Okay, now mind you, it's not what initially causes it. Okay. Obviously, there's different functions with Alzheimer where they believe, and this is still, obviously there's still a lot of data going out on this, and this is not research from that guy who was a fraud, just throwing that out there. They have there has to be some sort of thing that kind of causes the initial damage or pathway to allow these bacterial infections. It's almost like a it's like a complicated process where bacteria, we've got prions. Prions are bad, by the way. They're like a protein deposit, but you can't, with prions, you can't even sterilize them in some situations. They have to have really specific sterilization methods. So they're finding even with surgical equipment, you can actually pass on. There's a theory that you can pass on Alzheimer's because of this, but that's not actually necessarily what caused it. But the prions sort of like caused one thing, and it's almost like a chain reaction from there, and then you get a bacteria, and then a fungal infection happens. And they're finding like that it was like literally 10 out of 10 in the different groups where they had a control group and they had a non-control group, and they did autopsies on people that had Alzheimer. 10 out of 10 had a fungal infection in the brain, which was interesting. I think it was a prefrontal cortex, but I don't know if I wrote that anywhere. Okay, well, I think it's the prefrontal cortex where they found the hyphal structures, which I thought was very fascinating. And they also found that whenever they gave people antifungal, now this is still, whenever I'm telling you this is still progressive studies. Is a very small group of people that they did this to, so I can't say that this will help, but the ones that they gave this specific antifungal medicine to, it actually stopped the progression of their Alzheimer's. So I thought that was a very fascinating thing, and it shows that fungi can have a very big part. And Candida is one of the specific species. Is one of the specific species. Although, mind you, there were many that they found. But yeah, like previously they believed that plaque was like, high plaque was what was causing the Alzheimer, but that was actually just like a byproduct of what was happening, and controlling the plaque didn't have an issue.
My understanding is that the mycotoxins that the mold do, like aspergillus or penicillium or staphylococcus or
Okay,
Fusarium alternaria. Oh yeah.
that makes sense. That's interesting. I'd like that, but I did cite all this research, so I'd be happy to share any of this research with you for anyone who's interested. And that does actually make sense. So yes. No, this isn't going to happen. Okay. We're not going to become zombies. All right. It took millions of years for these to develop in insects. Okay. To get where they were. There's not going to be most fungi don't even like us because our body temperatures are too hot. So, but when we do get a fungal infection, it's really hard to cure them. Like if it gets in your lungs, that's not good. It takes a very long time to stop any kind of bad fungal infection, even with antifungals, because they're just real nasty. But that doesn't mean it's going to control our brains and cause us to infect our friends, like in this one. I love that comic. Anyway, so now that's actually my cat. He likes knocking things off the table. So yeah, I had my son's like kid microscope on the table, and he was like, "I'm gonna knock this on the floor." And but he looked like he was looking into it, so I took a photo, and then he did try to knock it on the floor after this. But yeah, that's Thor, mighty Thor. But there are other things that see, everyone's afraid of, the fungi infecting our brains and causing, us to, kill each other, kind of range thing. But there actually are things that are present that do influence our brains, like toxoplasmosis. And I put the kitty there because it's often spread through cats and me. So from what I was reading, about 22% of Americans older than 12 have actually had infections of Toxoplasma gondii. And it does cause some behavioral changes. There's people who have had previous infections to toxoplasmosis are usually more likely to be risk takers, more likely to have owned a cat, especially an outdoor cat. They're more likely to get in car accidents, more likely to be extroverted. And also those with schizophrenia are more likely to have been infected. But yeah, like I said, it's often spread through the cat feces. It's a whole cycle. Like there's the mice get infected and then the cat eat the mice. Like so the infected mice actually lose their fear of cats with this once it actually affects their brain. So this is like multiple levels of brain messing with your brain here. You got the mice getting infected, and then the cats eat the mice, and then they they use the restroom and some environmental thing like some mice go near the poop or something, and they get infected again. Or we're cleaning a litter box and we get infected. So yeah, I thought that was interesting. Also, they're finding now COVID-19 can actually cause behavioral changes in people. There's 16% of those that have been previously infected. That mind you, these are in control groups. So when you're looking at different studies, you have to think of how large of a group study that they've done. But they found that like 16% of those in their studies have depressive symptoms. 18% have reported PTSD. 45% demonstrated executive dysfunctions, which is really kind of nerve-wracking. That this can cause ADD. Think of like ADHD, like, see, I've lived with all my life, so if I get infected, I'm good. I'm like, just another day. Now you guys, now you get to turn into me, and you get to see what it's like to, try to hold a conversation and then float away. So, or try to do a speech while you're like, oh, this other cool thing. So yeah. Yeah, there's visuospatial issues. So like, bumping into things. 25, now again, the severity of these is to be said. They're not mentioning just how severe it is or anything. Did you want to say something? Oh, okay, I thought you were. So yeah, I just thought that was an interesting thing. So there are other things that you got to worry about more so than fungi. It'll probably take millions of years for something like that to develop in us fungi wise, for other than the ones that already do, and they've taken millions of years to get there. And these are my cool fungi that I found. Look, he's missing his butt. That's a really cool rare one. Good story. Yeah, so these are my citations, and that's it. Well, I hope you enjoyed it. Any questions? I might be able to answer them. Oh yeah, you want to? All right. So one of our regional, I'm gonna call him an expert, whether he believes he is or not. He's a regional expert. His name's Jeff Menango-Naro, and forgive me, I probably butchered his name just now. He has found that if you go near like areas that have acid mine drainage, you're more likely to find these cordyceps ones, right? And these entomopathic ones, if you look at the undersides of leaves, or I mean, sorry, the entomomorphisae or whatever, entomomorphical, those ones like these guys here, you look on the underside of leaves, underside like on grasses and things. But these ones, the cordyceps or the orthocordyceps, they tend to be inside like logs. So I like to like really check logs out. And this one in particular, so you can see this is actually a specific larvae here. I think I forget the name of what the actual one is, but this makes it a different species than the normal militarius. Yes, I think it's a beetle. You may, I forget. I should have known better. But yeah, a lot of pupae, a lot of moth pupae get infected. That's usually with the militarius. This one, I think it's a moth. This is a weird one. This was a kind of a rare one, so I don't even know. I tried to ID it, but I don't know. This one's another weird one. I don't even know. I found this one in moss. So, but the, usually these like little guys, like the Orthocordyceps, they like to, kind of burrow into things, and you'll find that they sort of fruit out of the ground. So if you're trying to look for these guys, that's where you'll find them. For the salt sakers of death, you have to wait 17 years. So, but these guys here, this is a millipede. Again, I find them on literally like you see here, top of logs. They tend to be literally like right on the top of logs. So, any other questions? So when it comes to things like this, they have to go through a lot of because to go through a lot of testing before they can release it, because you don't want to have a worse situation than you had previously. But yes, they are currently testing different, and it's not just for the ones I've mentioned. There's quite a few different things.
So I think that it is being culture, and I do know of guys who are using it on small farms. They're making their own solutions and find out. I believe Jeff Maganara,
He's one. I think I've given him some. Mm-hmm.
Yeah, there are cultures available. You do get a culture. If you have to try to create it, you are familiar with it, tissue transfer,
Mm.
and then you can or in a solution with it, spray your plants, spray something.
Yeah, unfortunately, a lot of the times, like he was saying, it's almost like localized with some of these. You wish it would like really spread out, but a lot of these things evolved so they wouldn't kill everything, because if it did that, it wouldn't be able to propagate. So is there? I didn't know that. That's really cool. That's good. Kill them. Yeah, they have psilocybin, which is
The spores that happen. And then how do they stay?
a lot of them like. Oh, I'm glad you asked, because I love talking about this. Okay, so roots, like when you have a tree, a lot of trees have rhizomes underneath, okay? And without those rhizomes, which is sort of like a fungal tree relationship, they'll die. They help them get like these fungal infections that they have in their root systems, so to speak, will actually help them to gain more nutrients in many ways. So they sort of like kind of hang out in the root system, and yeah, they just kind of continue on through there, and they won't like seeds won't fruit unless if there's water or something, right? Well, a spore won't fruit unless if it has its mechanism of fruiting. So yeah, it's like that.
With the,
Yep.
is that just a fact?
Actually,
Will affect the other diseases.
well, okay, so that one is mainly with periodical cicadas, but there are other fungal infections that cicadas can get. And one of them is from the Orthocordyceps, which it was recently found. And they're still doing genetics, and they didn't even describe it yet. So, but it's in the other phylum, which I thought was kind of interesting. But there's also, I think, another one that's in the entomorphs. Should just make up a name for that, like the entomorphs. There we go. Make life easy. Oh, I'm like bumping the mic here. I'm like, oh, poor people watching online are like, oh God. So, but yeah, so there are other fungal pathogens, but they have different mechanisms of transporting. This one, they don't even know. They're just like, whoa, we found one with this. How'd that happen? So, like, until we find more and are able to study how its fruiting behavior happens, we won't know. It's a lot of fungi, and even like there's a lot of insects. We have no idea how they even reproduce. So until you find them and see them actually doing it, like, it's hard to figure out how that whole cycle takes place. Anyone else?
So, so our but for like ransom-wise, what is the goal? But if it's not possible, and it isn't able to, come back assisted, evolve in the lab, and you just keep running and spraying, and so it wouldn't be just one spot and okay, then you step up away.
Right.
Then it can evolve and other, like not one time, but it's doing because it's always looking for that.
Mm-hmm. You know what? I don't know. I think it depends on the fungi itself. I think with certain, it's almost like, so for example, this isn't fungi related, but flies. The reason why we use fruit flies for a lot of different studies is because they breed really fast. So they can evolve really fast. I am just hypothesizing that it's something like that. Like, obviously you don't, if you study elephants, it's going to take forever. And like, you have to have a bunch of lifetimes of people to get through the lifetimes to see evolution in something like elephants, because they have such a long lifespan. So, again, I presume it's something like that. Depends on its mechanism, its cycle, because they're, different fungi in their different phylums will sporulate different ways. So something in agaricils will spore completely different than something in the piezoeals. That one. So like there's actually some fungi that will, like, they've evolved to where, you bump them and they like shoot the fungi, like they just shoot the spores all over the place. Some of them go as fast as a bullet. And then there's some that just kind of lay in wait for you to come get it, and they just like, but yeah. So I guess it really would depend on the actual fungi species that you're looking for or looking at.
Any other research, did you find that any of the fungi could share, like in bacteria, they can share plasma? So one bacteria might have some kind of resistance or some attribute, and the plasmid into a second bacterial line. Anything like that in our fungal world?
Like where two different fungi can work together. Oh, absolutely. Absolutely. On the spot right now, I can't think of it, but I know that there are different fungi that will absolutely work together to support each other's life cells and life cycle. So, yeah, that's definitely. Sometimes fungi will work with bacteria. I mean, like look at Alzheimer's. Look at all the different kind of things that had to happen for you know, the hyphae to get into the brain like that. Anyway,
Do you think there is enough on the subject of another meeting about fungal parasites?
yeah. So like abortive entoloma. Yeah. So like fungi that parasitize other fungi or pathogenize. So yeah, like Entoloma abortiva would be one of them. You have hypomyces, that parasitizes boletes. Yeah, you could do a whole thing on fungi that parasitize other fungi. In fact, we have an expert on that right back there, and he's writing a nice little book on it. I'm gonna put him on the spot so you can feel awkward. That's John Plischke over there. He would know more than anyone, I would say.
Yeah, I published the first draft of the piece on that.
But yeah, and again, those are also very species specific. So you can figure out what it is just by knowing what the host is. In many cases, not in all cases. Sometimes there might be multiple ones that parasitize the same host, and they might be in the same genus, but you can separate them by like guttation, which is like the water, well, like the liquid that can be exuded from the fungi, you know. So yeah. Anyone else? Nope. All right. Well, thank you for bearing with me and my crazy brain.
Yeah. Thanks for watching. Thanks for being here. Have a great night.